All right, welcome to Industrial Talk. We have Nitin, Das, and Rahul Saxena. All right, we are talking AiDash. We are talking about satellites. We're talking about utilities. We're talking about how the use of satellite technology, AI, is going to significantly improve vegetation management within the utility space. And as an old crotchety, crusty journeyman utility lineman, I love this topic. So I will be geeking out, listeners, because, well, it's an important topic to have. And I think it's going to be just absolutely transformative when it comes to managing vegetation within the utility space. I like it. It's a cool topic. All right, before we get into that, Nitin, for the listeners out there, give us a little 411, a little background on who you are and why you're such an incredible professional. And then I'll throw it to you, Rahul.
Hi, everyone. I'm Nitin. So I'm one of the co-founder and chief AI officer at AiDash. So here in AiDash, I'm basically taking care of all the research and development over AI/ML solutions. I have around 18 plus of years of experience with a computer science background. And for the last many years, I'm mostly into AI/ML technology and building solutions around that.
I have a number of conversations with AI technology, machine learning, simulations, data, and all of that stuff. And this is a fascinating, and you're right at the cutting edge, which is very cool, of how you're deploying that AI platform technology in the world of satellites, which benefits us. And I'm a big fan of that. Rahul, give us a little background on who you are.
Yeah, hi everyone. This is Rahul. I'm co-founder and CTO at AiDash. So around about 20 years of experience. Some of them was work around building enterprise security software. So did a lot of, right from design development to management around building these softwares for large enterprises, Fortune 500 enterprises, a bit of startup experience in the B2C space. So mix of, entrepreneurship and technical roles. So at AiDash, I look at, building all these different cool applications based on the cool stuff which Nitin is doing in the AI side and building the platform around that.
See, this is going to be a great conversation, as I alluded to, just because we've got two incredible professionals with mad skills in the world of technology. And what makes it exciting for me, outside of the fact I love the utility space, the power space, the energy space, is that I think there's a tremendous transformation that is going to have to happen within the utility world. And I think that it's wonderful that you guys are leading that charge. Now, many of the listeners, and I am going to be candid with you, many of the listeners know of satellites, know of, hey, I've got my dish and I guess I'm getting, but there's a lot more to it. If you could give us, Rahul, some sort of that historical perspective of satellites and sort of lay that foundation, and then we're going to expand from there.
Sure. So the first artificial satellite, or the era of remote sensing, began with this satellite called Sputnik 1, which was launched as early as 1957. So it's been around 65 years since the first remote sensing satellite was launched. So that was the first satellite which could complete the orbit of Earth every 96 minutes and can transmit signals which can be received by Earth, right? That's where the remote sensing era kind of began back almost 65 years back. Over a period of time, this space has really evolved. So it started with, let's say, a single sensor, which was more optical, and you can just see the camera image, what you see for your normal camera. Eventually from, let's say, 60s to 80s, it started getting into multispectral, which started capturing more bands. And Nitin is an expert that can deep dive more into, what those bands are. From there, we got into radio images, thermal images over next 2 years. And I think for last couple of decades, the journey has been, rather than having very large satellites, to what they call nano satellites or smaller satellites, which are very small. And rather than, launching a very large satellite, which is very costly and takes a lot of time, you can actually have a very small dimensional satellite, which you can launch multiple of them, have a constellation of them. So that's where the world has evolved.
I'm writing this stuff down and I'm going, nano satellites, man, a cluster. That is incredible. I didn't know. And what's interesting, back to Sputnik, really the premise behind Sputnik as a result of just a satellite is to be able to say, it's transmitting, beep, 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 whatever it is, and we're receiving. So we've just proved that we can do up here, and receive whatever that signal, and that is a leap forward in the advancement of technology. I've got to ask, and this is to you, Nitin, how many satellites are being launched every year, right? And then can you explain for the listeners, and Rahul mentioned it, bands? I don't know. Explain a little bit of that.
Sure, definitely. So as we have seen the natural progression of the satellite, these days, 1,000 new satellites launched every year. And I would like to say basically the different type of satellites started from Earth observation, then terrestrial, multispectral satellites are hyperspectral, and multi-sensor satellites are there. So in the multispectral, basically there are multiple bands having different frequencies and different wavelengths. So those are called basically the red, green, blue, red edge, that is shortwave infrared bands, and combination of these bands can be used for solving different kind of problems. So that is basically the multispectral part. There are the different kind of satellites called the thermal satellites. Basically they capture the thermal signature of any object on the earth. So that is the thermal satellite. Hyperspectral satellites basically having more than 200 plus continuous bands, and they basically will open up a new era for solving different kind of problems, which can be solved through multispectral satellites. And there's another kind of satellite called SAR, that is a synthetic aperture satellite. If you look at optical satellites, there is a limitation. They can't see in the night and can't see through the cloud. But there are synthetic aperture satellite. Those are called radio satellites. They can penetrate through the cloud, and they can also see objects in the night as well. So these are the different kind of satellites with their corresponding bands.
Of the satellites, and you bring up a good point, because you just said, hey, satellite could be this, satellite could be that. This is, and we can see this, we can see whatever. It's amazing technology. If I'm a satellite person, how do I manage that 1,000, new satellite inventory given what I have here? Right? What is being launched? That's to you, Nitin. How do they make that determination? Or are all satellites multi-capable?
No, so all the satellites are not multi-capable. So there are basically multiple sensors installed on a single satellite. But for example, let's say thermal satellite. So there's a single sensor, there's a thermal sensor, and a SAR satellite, there's a single SAR sensor. So based on the use case, based on all other things, they basically installed multiple sensor or multiple camera on a single satellite.
And it's just going to get more and more, right? It's just, and the technology, it's just going to continue to advance, and it's just like anything else. It's definitely not static. It's a very dynamic type of environment. Yeah. Now let's talk a little bit about that. Me, old crotchety, crusty journeyman lineman, I'm all about that human inspection. I got in a truck and I went down, I looked at that tower and I climbed that tower, and then I looked at that insulator. And that was very labor intensive, right? And so then here comes drones. Drones were like, all right, here, and I can see it and take great pictures. And then of course, LiDAR and so on. Explain to the listeners of the difference between, let's say, the drone, LiDAR, human approach versus the satellite, why that is so, I think that's transformative. Rahul.
Yeah, sure. So I think the biggest difference there is in terms of sheer scale, which satellite can do. The satellite, like I mentioned, starting from Sputnik era, which was covering the whole Earth in 96 minutes. So there's a massive coverage, which is happening pretty rapidly, right? So none of the options you mentioned, like LiDAR, whether it is for a drone or a helicopter, or obviously for human beings, it's not possible to scale at that rapid a speed. So for example, a satellite can capture very large areas, like up to, let's say, 1,000 square kilometers, which is just not possible in, drones or, from a human angle. So that's one of the major differences. The resolution might drop a bit, but it is more than compensated by the sheer scale by which, you can get this imagery. Apart from that, since satellite imagery, keeps taking the image and keeps sending it to Earth, over a period of time, you get archivals or archives of these imagery, right? So if I'm looking at an area, I'm not just getting an image as of today, right? Whether it is human or drone or LiDAR, you can just capture what is there today, right? Unless you have been doing this for a very long time. In satellite, I can actually go to the past and make a future prediction, right? I can see the pattern and make a prediction based on that.
I like that. And listeners, that means that I have a picture. Let's say I have a picture a week ago. I have a picture today. I have a picture a month ago. And Nit, correct me if I'm wrong, through the AI capability, be able to determine, because the key here is, and I would imagine, correct me, is that, hey, I'm a utility. I have vegetation management. That is a cost to me. And I want to deploy my money efficiently. Don't go over here, go over there, and be able to communicate and deliver that type of insights because you have those multi-pictures vision from above. Is that correct?
You take pictures at multiple point of time, and you can basically estimate the change between these two images, and that change can be translated into a problem statement, something like that.
Yeah, when I was doing patrol work, the reality is if there was a rain and there was a eucalyptus, I knew that was going to grow, and so I'd have to get in the truck and get my, and go out there and cut, or waste my time and go out there and say, oh, I still have clearance from whatever the power line, or whatever it might be. It is the ability to be able to truly deploy my money. This is, dollars and cents, my maintenance dollars in vegetation management to the right. And can I see the type of tree it is? Like the type of tree, here's eucalyptus, here's oak, here's this. And be able to also have that determination. Is that a possibility? See, you can see I geek out on this stuff because I had that same problem. Can I do that?
I'll just give you a high level and then maybe you can add to it. So yeah, I think there are two things here. The other angle here is it also depends upon what you need from this solution, right? So if in satellite imagery, I can go back to the past, all I'm looking at is whether it's a eucalyptus tree, whether it is some other tree, what's the growth rate, what's the clearance, right? So if I'm inspecting manually, so if it is a eucalyptus tree, I understand the growth rate and can make a cycle trim prediction based on that. But if I am, just having this data independent of the species of the tree, I can make a prediction independent of the species of the tree, right?
Yeah.
So knowing the species of tree becomes slightly less important.
So with the current set of images, you can basically get the state of the vegetation. But with the historical images, you can estimate the growth rate of each of the tree without knowing the species. We don't require the species because we estimated the growth rate of each and every tree within a given area of interest.
Do you also, in your AI solution, incorporate weather?
Yes, weather is an important factor, which basically weather, soil, all these variables are the part of AI model.
There is a lot of chatter, a lot of discussion around disaster management. We see it, right? It just happens. Sadly, it will happen again this year, and we're going to have that same conversation, and it's just going to. With AI satellite solution, how does that help with that? How does it minimize and be able to sort of elevate that disaster conversation?
Sure, definitely. So I'll basically give an example of how the satellite can be used in the wildfire. So there are three components in wildfire: the pre-condition before the wildfire, during the wildfire, and the post after the wildfire happens. So before the wildfire, the satellite data is used to identify the wildfire risk zones, which can be used for hardening the infrastructures. If we already know in advance what all areas are important for wildfire perspective, low, mid, high, categorize those, then utilities can take appropriate actions before time for hardening the grid and all those things. During the wildfire, because there's a natural calamity which can't be avoided, so if the wildfire is happening, so satellite data can be used for basically estimating the direction and the speed of the wildfire, and then the utility can take appropriate actions. For example, the evacuation on time. Post-wildfire, basically, the post-wildfire damage can be estimated through satellite data, which can be used for restoration and many other purposes.
I'm having a hard time poking holes in your value proposition for utilities. I mean, it makes sense. So if I'm a utility, and I've had this conversation with utilities, is that they're having challenges just like everybody else. And the challenges is, I got workforce management, how do I find the right reputable tree company to trim? And then how do I do it? They're struggling. And this is a huge budget component to their business. It just is. If I was a utility company, I would definitely take note, because I think that this is only going to get better, right? Let me ask you this. So with that statement, it's only going to get better. Where do we see it going?
Sure. So I think one way to look at it is extrapolate the history discussion we had at the beginning of this conversation.
Yep.
So it's going to continue the same way. We had till nano satellites. We are talking about actually pico satellites now, which can be even smaller. So more satellites and more coverage. We are also looking at, as more of this image becomes available, I mean, there'll be some commercial satellites. So more data becomes available, more kind of models are possible as we go along. The AI becomes better. And then as we are going forward, and especially this becomes important for things like, monitoring for, let's say, a wildfire or a storm and those kind of things. So the travel between, the signal coming from space to Earth, a lot of work happening on that side as well, right? So how to reduce that time? So the moment a satellite captures, are there ways the signal can be captured very quickly on Earth so that some action can be taken? So those would be other areas which we feel there will be more advances.
I keep on stubbing my toe on the nano idea. I just have to ask it. How big is a nano satellite? I mean, just physically.
So when the Sputnik or the initial phases of satellite, those satellites, basically the weight of those satellites were around 100 to 500 kg, a single satellite. Okay. Then there came the micro satellites. The weight got reduced to 50 to 100 kg. Then there came a nano satellites. The weight still got reduced to less than 10 kg. And there's a newer set of satellites. The weight is around 100 grams to 1 kg. So that is the new set of satellites.
Come on, listeners, you got to admit that that's pretty cool. That's a great conversation. Oh, that's exciting. And you know what else? And I sort of dovetail. Everybody's talking about all the stuff that's in space right now, but those really small satellites address that. I mean, it's not a big clunky thing out there, right? They really do. They address that. And from a cost perspective, I mean, I can throw a bunch of them in there and zip it out there. And so I get greater bang for the buck for that rocket.
I would like to add one more thing. So along with basically the change in the size of the satellite, there's also increase in the resolution. So basically, initially the resolution was around 50 to 100 meters. And now the resolution is basically 30 centimeter, 20 centimeter, and 50 centimeter, very high resolution satellites we are.
It's going to continue to be better. It's just going to continue. I don't know if I'm scared or excited or whatever, but that's a heck of a conversation. All right, we're going to have to wrap it up outside because I'd love to continue to talk about it. I got to tell you, gents, this was a great conversation. I really enjoyed it. I know that we're just really just scratched the surface on what you guys are doing at AiDash and what's taking place. You are passionate about helping utilities and their vegetation management, leveraging the technology, leveraging satellite. Heck of a conversation. Well done to you both.